Today we're going to be talking about unit rates, and we are going to find and use unit rates. The first thing we need to do is define what a rate is. A rate is a ratio, and a ratio is a comparison of two quantities by division that compares two different kinds of quantities or measurements. So the ratio is just the way that you write the rate. Okay, and there are three ways to write ratios. Okay, and these are the three different ways that you might see rates written. 3 aides for every 24 students. So you can write a ratio like this: 3 aides to 24 students, where it looks like a fraction to you. Then you can also write 135 words and then a colon. This is another way to write a ratio in 3 minutes. Okay, and then you can also say 7 adds and write the word 2 for pages. All three of these are different ways to write ratios to represent the rate. Rates are often expressed as unit rates. That is, with the denominator of 1 unit. So we're going to express each comparison as a unit rate. So we're going to change the denominator to 1. So if I have 300 miles to 6 hours. Okay, and I want to change my denominator to a unit of 1. Well, what do I do to 6 to get to 1? I have to divide by 6, right? Whatever I do to the bottom, I have to do to the top to keep it equivalent. 300 divided by 6 is 50 miles. You always have to label in 1 hour. So we can figure out how far do I drive in 1 hour? I'm driving 50 miles in 1 hour if I drive 300 miles in 6 hours. Okay, let's look at this example. 275 square feet in 25 minutes. Square feet can also be written as feet squared, as for an abbreviation. It makes it shorter for 25 minutes. Oops. So if I wanted to figure out how many feet I could do in 1 minute, how would I get from 25 to 1? I have to divide by 25. So I divide my numerator by 25, and 275 divided by 25 is 11 feet squared. So I can cover 11 feet squared in 1 minute. When you find unit rates, it makes it easier to compare different things. Like if you were in the grocery store and you're looking at buying a 2-liter of soda versus 6-pack of soda, if you compare the difference for 1 unit, it would help you figure out which price was better. So unit rates are often used. When two quantities being compared in the rate are both fractions, the rate is expressed as a complex fraction, which is a fraction that has a fraction in the numerator and the denominator, or either or both. So we want to find each unit rate. So in this case, I have a fraction in the denominator. 15 miles for every 1/2 hour. Okay, we're going to do the same thing down here that we did up here. How do we get rid of the half? How do we change that to 1? Well, the same thing I did here. If I have a half here, I have to divide by a half. That's going to equal 1 hour. Whatever I do to the bottom, I have to do to the top. Divide by 1/2. Well, this goes back to the division of fractions that we did in lesson 1.6. So the first thing I need to do is change this 15 and put it 15 over 1 divided by 1/2. Well, remember, we don't ever divide fractions. We always multiply by the reciprocal. So 15 times 2 is 30. 30 over 1. So 30 over 1 is the same thing as 30, so I have 30 miles in 1 hour. You may have been able to look at this and think, okay, if I travel 15 miles in a half an hour, well then if I just double that, I can double the amount of miles I travel and I would get 30 miles. And that's an okay way of thinking about it too. So let's look at my next example. 1/4 cup for every 2/3 minute. Well, this time I have a fraction in both the numerator and the denominator. So I'm going to have 1/4 cup for every 2/3 of a minute. Okay, so my ratio is 1/4 cup to 2/3 minute. Well, to get rid of what I have in the denominator, I always divide by whatever it is. So divide by 2/3. So I have to divide by 2/3. 2/3 divided by 2/3 is going to be 1 minute. And 1/4 divided by 2/3. Well, I know that I cannot divide fractions. I always multiply by the reciprocal. So I have 1/4 times 3 over 2 over 1. 1 times 3 is 3. 4 times 2 is 8. So I get 3/8 of a cup for every 1 minute. That is my answer. I should have also boxed this answer, sorry. 30 miles per hour, 3/8 cup for every 1 minute. Okay, let's look at this word problem down here. It says, while remodeling her kitchen, Angela is repainting. She estimates that she paints 55 square feet every half hour. How many feet does Angela paint per hour? You may think that you could do this pretty easily in your head, but we're going to go through the steps so you can practice it, so that when you have a problem that you can't do in your head, you know what to do. The first thing we have to do is determine the units of rate. Well, I know that I'm calculating square feet per hour. How many square feet she can paint per hour. Those are my units. Now I want to find Angela's rate of painting in the area painted per time. So I'm going to fill in the numbers I have. I have 55 square feet, or feet squared, same thing, per every half of an hour. Okay, well, I'm going to divide the bottom by 1/2. So I have to divide the top by 1/2. And that's going to equal 55 divided by 1/2 over 1 hour. And remember, we don't ever divide fractions, we always multiply by the reciprocal. So I need to put 55 over 1 first, times 2 over 1, which equals 110 square feet per hour. And I actually went ahead and did step 3 up here. So my answer is 110 feet squared, or square feet, per hour. And that's Angela's unit rate.